All right, here we want to find the distance between the 2 points. And there are two options for doing this. One, I could go ahead and plot these, grab some graph paper, plot these points on a graph. And now it'd be just like the problems we've been doing. If I have the 2 points on a graph, I just have to count up and over to get from one point to the next, or down and over. I draw a right triangle to get from one point to the next. And then I use my Pythagorean theorem to find the distance diagonally. All right, so that's option one. Grab some graph paper, plot these things, and do what we've been doing. All right. Option two is if we know that we're going to use a right triangle, and we know that when we find the distance or count the distance on the graph from one x value to the next x value, it gives me one of the legs of the triangle. And then when I do the same thing with y, it gives me the other leg of the triangle. I can simply draw a right triangle here without actually graphing it. I'm just going to find the length of each leg. For example, I would say this. I would say, okay, so the distance from x to another x value, that's going to give me the leg, the horizontal leg of this triangle. And so let's find the distance here. I can find the distance just by subtracting. 7 minus 3 is a 4. And I can subtract it the other way as well. 3 minus 7 is a negative 4. But remember, distance is always positive. So if I subtract and get negative, just make it positive, and that's the distance. All right? Doing the same thing with the 5 and the 1, the distance here will give me the other leg of my triangle. It'll give me kind of the vertical leg of this triangle, okay? And so once again, I can find the distance just by subtracting. Let me do it the other way. Ready? 1 minus 5 is a negative 4, so the distance then is just positive 4, okay? It's okay to subtract and get a negative. I just make it positive. I'm talking about distance. And so this is what it gives me. It gives me the legs of my right triangle. Now I just have to find the hypotenuse. Okay? And this is the same thing that would happen on the graph. Granted, this right triangle might be facing a different direction. You know, it might be a right triangle where I went up and then over and then counted the distance, found the Pythagorean theorem this way. But either way, it gives me the same distance. So really, I could plot these and I could count the distance for the legs of the triangle. Or I can look at the x's and get the distance by subtracting. I could look at the y's and get the distance by subtracting. But either way, those distances that I'm either counting or finding through subtraction give me the legs of a right triangle. Now I can use my Pythagorean theorem. The side that I'm missing this time is this one, is c, is the hypotenuse. So now I do legs squared plus legs squared equals the hypotenuse squared. That's 16 plus 16 equals c squared. I simplify by combining like terms. So I add those together. And I remember to solve here, I just take the square root. To solve when I have something squared, I take the square root. And so for this one, this is, again, is a job for my calculator. I'm just going to plug it right in. The square root of 32 gives me a 5.7 when I round it off. Okay, so the distance, that's approximately 5.7. So I'm going to write it as D for distance instead of C, okay? Because again, we were talking about this generically, not about the side of a right triangle. We made it the sides of a right triangle so we could find the distance, okay? If I look at the next one, same kind of thing. Let's look at the x values. Well, let's find the distance of those x values. So again, that's going to be one leg of my triangle, so let's find this leg. To find the distance, I just subtract the two. 8 minus a negative 4. And if I plug that into a calculator, 8 minus a negative 4 is a 12, okay? Again, if I do it the other way, negative 4 minus 8, it gives me a negative 12. Distance is just positive. And now I find the distance of the other two. Ready? The 2 and the 0. So I subtract to get the distance. When I subtract those, negative 2 minus 0 is a negative 2. But because I'm talking about distance, I just make it positive. And again, it's just giving my distance in two different directions. When I subtract the x values, I get the distance going left and right. And when I subtract the y values, I get the distance up and down. And so this is the right triangle that I'm talking about. I just need to find the hypotenuse. So I'm looking for C here, okay? And so once again, we're doing the same thing. We're just cutting out the graphing step. And if that makes you uncomfortable, that's okay. Go grab some graph paper, just plot these points, and do exactly what we did in the previous couple problems, okay? So here, a squared plus b squared equals c squared. Again, that's a 4, a 144. I add these up, that's a 148. And of course, to solve when I have something squared, I take the square root. And again, this is a job for my calculator, square root of 148. So I get 12.2 when it's all said and done. Okay? And again, in my triangle, that was C, but really I'm finding the distance, so I'm going to call it D. Okay? So again, we find the legs of the right triangle, and we use the Pythagorean theorem to find the distance. Okay? And really, we're just mimicking what we did on the graph, but without actually graphing it. Okay? And if that makes you uncomfortable, go ahead and graph these and find the distance using your right triangles from the graph. Okay?